This is the 6-9 worksheet assignment, and we are going to be graphing linear inequalities. So, taking a look at number 1, this is in nice y equals mx plus b form, where we have a slope and an intercept, and that's the y-intercept. And so we can start at the y-intercept, which is where it hits the y-axis, and then use the slope, which is negative 3 over 1, so down 3 over 1. Go in the opposite direction, up 3 over 1. To plot this out, now first of all, this says less than. Before we even worry about shading, it does not say equal to, and equal to would have a solid line. So we're going to go ahead and draw a dotted line through those points, meaning the line is not included in the solution. Okay, so if a point was found on the line, it would not make this true. It does say y is less than, so we need to shade the area that's less than, which would be underneath. So since you can see it tilted this way, above would be this, below would be here. The other way to think about it is think specifically of the y values. The place that this crosses the y-axis is at positive 2. Since y is less than, we're going to highlight the area with all the numbers on the y-axis that are less than 2, which would be down here. If we shaded the upper region over here, we'd be shading numbers that are greater than the 2 for the y, and so the correct shaded region is down here. In terms of your shading, it doesn't have to be perfect, but it needs to be clear that everything from the line over and down is part of the region. Okay, so there shouldn't be a gap here between your shading and the line. Okay, number 2, intercept is 1, slope is negative 1/4. That's down 1 over 4. Can't fit the next point, so I'm going to go up 1 over 4 this way. There is no equal to, so this is a dotted line. In terms of your shading, it says y is greater than, so I'm going to go to all the y values greater than my line. And let's just reinforce what this means. If I take any point that's in the shaded region, it will make this inequality true. I plug in for y, I plug in for x, I simplify this side. The left side will be greater than the right side. And if I pick any number that's down here, not in the shaded region, and plug them in for x and for y, it will make an untrue statement. And that is also going to hold true for right on that line. It's dotted, so anything on the dotted line will not make this true. The dotted line is going to make this true if it was an equal sign. Okay, and since it's a greater than sign, though, it's not going to work. Both sides will come out equal, so it'll say some number is greater than itself, which obviously is not true. And so that's what you're going to find on the actual line. All right, let's speed it up. Number 3, intercept 4. Now, coefficient of x is 1, so that's my slope. 1 over 1, up 1 over 1, up 1 over 1. So we're going to go diagonal here. Now, this says less than or equal to, so since it's equal to, we have a solid line. And less than, all the numbers less than would be down here. Number 4, intercept's negative 1. Slope is negative 1 over 1. So down 1 over 1. All the way across. So it's going to go diagonally here. And this says greater than, so this is a dotted line. And the shaded region would be everything up here. Number 5, the intercept is 5. Slope is 2 over 1. Up 2 over 1 doesn't fit, so I'm going down 2, 1 this way. Always double check yourself. After you've drawn your line, make sure you have a positive slope, because that's what we have. If you went down 2 over 1 this way, you'd be creating a negative slope, and you should see that that's a mistake. This does have the equals to, which means the line's included in the solution set, so we need a solid line. All the values that are greater than y, so here's 5, everything greater, 6 and up, is above this. Number 6, starting at negative 5. Slope is 7 over 1, so up 7 over 1. You're only going to fit 1 point on the graph. It is not included. This is a dotted line. It says greater than, so look where we're hitting the y-axis. The numbers that are greater than that are above it, which would be this region. So everything in the shaded region is part of the solution set. So number 7, we are at -5. And we're going down 7 over 5. So clearly we can't get to it. So you need to picture it. If I went down 7 over 5, I'm down here somewhere. So my next point, if you followed that line, is going to be out here. So when you go up 7, make sure you go left 5 to keep this a negative slope. If you go up 7 to the right 5, you've created a positive 7/5 slope. We need a negative, so it's got to go this way. So up 7 would be to the 2 over 5 is right here. There's an equal sign there, so that's included. This is a solid line. And it says greater than, so everything greater than is up here. Number 8, starting at -1, we're going positive, so up 4 over 5. I can go the opposite way, down 4 over 5. Dotted line, because there is no equal sign. The line is not part of the solution. Everything is greater than is part of the solution. So we are shading above this line. Number 9, starting at -4, slope's -3 over 1. So down 3 over 1 will not fit. Picture where it would be though, down here. So the line has to come up this direction. So go up 3 left 1, up 3 left 1. We have an equal sign here, which means the line is part of the solution, meaning we have to draw a solid line. It says less than, all the y values less than -4. That's -5, -6. That is below this line. Everything down here. Number 10, crossing at 1. Slope is -1. Remember what that means? -1 over 1, that's down 1 over 1. And we're going to have a dotted line here. Oops. It says y is greater than, so we are shading all the y values that are above our intercept. Number 11, there is no plus or minus here. That means it's like a plus 0, so we are hitting at the origin 0, 0. Slope is up 1 over 5. So I go down 1, left 5 from my other point. It is included. This is a solid line. Everything greater than, in terms of y, is up here. Number 12, starting at 3. This is down 8 over 1. Down 8 is down to -5 over 1. There's an equal sign, so it's included. Draw a solid line. It says greater than, so be careful here. This line is almost vertical, so it's easy to be confused which side to put this on. Here's your y-intercept of 3. We need everything greater than in terms of y, which is going to be everything above that line, which, because it's so vertical, looks like it's just to the right, but that is above it. You can always take your line and just continue the tilt that it's on and think about what's above it. Okay, and that's the right side in this case. Okay, as we flip to the next page, number 13, now we're given equations that are no longer in y equals mx plus b form. So we have a couple options. We can get them there. This, for instance, is one that's very easy to get there. All you have to do is minus 2x. It goes on the other side. You're all set. So let's try that. If I minus 2x from both sides here, it goes away, and I'm left with y less than or equal to -2x positive 2, so plus 2. So that just means I'm going to go up to 2, and I'm going down 2 over 1 all the way across. I do have an equal sign, up 2 over 1 to continue this way, so it should be solid. It says less than, all the y values less than are down here. Now, for these that are given in standard form like this, with the x and the y, a, b, and c, we talked about you could find the intercepts, the x and y intercept, by plugging in 0. So if I plug in 0 for x, it'll give me my y intercept. So it's 2, which we got here. So it's x is 0, y is 2. And vice versa. If my y is 0, cross that out. 2x, and when you do this, you want to think about it like it's an equal sign. 2x equals 2, divide by 2, and it's going to be 1. And you can see right here, when I went down 2 over 1, I hit that x-intercept of 1, 0. So if you want to do it that way, you can. When I come over here to number 14, because there's so much going on here, I'm going to prefer to find my intercepts. Because if I plug in 0 for y, so that's going to give me a point that looks like this, 0 for y, cross this out, 3x equals negative 15. If I divide by 3, it's going to be negative 5. So negative 5, 0 is going to be a point on this graph. And vice versa, if I plug in 0 for x, cross that out, you have negative 5y, you have negative 15. You're going to divide by negative 5 on both sides. That's going to create a positive 3. And so my intercept here is positive 3. That's going to be my line. Okay, I've got an equal sign. So this is positive. And the y would always be on this side. So y is greater than. Now you got to be careful here. It looks like y is greater than. But since we've got this negative 5 on the y, if we went through the process of getting this in y equals mx plus b form, the last thing you would do is what? Divide by negative 5. We know when we divide by a negative and we're dealing with inequalities, they flip the other way. So in the end, when y is by itself, if we solve for y, this would end up flipping this direction and say y is less than. And so the shaded region is going to be down here. So this is where it could get a little tricky. If you're trying to use the intercept method to plot your points in your line, you're going to have to look at the coefficient of y. If it's negative, you're going to have to flip your sign the other way when you're thinking about your shading. So let's walk through the other strategy real quick. If we were trying to get this in y equals mx plus b form, we would first move x. We'd be left with negative 5y. Then we would divide by negative 5. And because we divided by a negative, this flips, says y is less than or equal to. Negative and a negative would be a positive 3/5 x, that's my slope. And a negative divided by negative is a positive 3. And if I was plotting this, I would go to 3 on the y-axis, and I would go up 3 over 5, and then down 3 over 5. And that would draw the same exact line, but you can see it says y is less than, so I got a shade down here. So it doesn't mean you can't use the intercepts, but you're still somewhat going to have to think about this strategy and think about, am I dividing by a negative at any point? Now, we don't care about the x, because even if this x was negative, I'd be adding 3x to both sides, which doesn't flip this. The only time it flips is when you're dividing, and the only time we're dividing is when we have a number attached to y. Okay, so you can always glance at the positive or the negative value of your coefficient for y, and that's going to tell you if you're going to need to flip this. Okay, so for 15, you could start moving stuff if you want to, perfectly fine. You could also find your intercepts. If I plug in 0 for x, 5 times something is going to be negative 10. So y is going to be negative 2. That's 0, negative 2. Plug in 0 for y. X is just negative 10. So it's negative 10, 0. And if you look at your graph, you're like, whoa, negative 10 on my x-axis. I don't even have that. So this strategy might not be the best one for here. So this is true. My x-intercept is negative 10, but it's not going to fit on my graph. So let's go ahead and use the other method, minus x from both sides. I have 5y less than or equal to negative x. That's a negative 10, so I minus 10. Now, I'm dividing by a positive. So there's no flipping here. This is going to stay y is less than or equal to. Negative and a positive stays negative. That's really a 1 on top. So it's negative 1/5 x minus, and this is 2. And you can see, here's my negative 2y intercept. Here's my negative 2y intercept. It's the same. And using this slope, it's down 1 over 5. If I'm going the other way to extend this way, it's up 1 over 5. And let's go back to our x-intercept for a second. If you think about it, if from this point I went up 1 and over 5, I'd be hitting the x-axis, If I go left 5, what number am I at? I'm at negative 10. So this would hit that x-intercept of negative 10. Okay, now in terms of graphing it, I do have an equal sign. So I have a solid line here. And it does say less than, and so I have to shade everything underneath of it, or all the y values that are less than my intercept. Okay, 16. For this one, since we've got some easy numbers here, I'm going to go ahead and move some stuff. Now we have to take notice of the minus y. That's like a negative 1. So I am going to have to divide by negative 1 at some point to get rid of it, which means this will end up flipping this way. This will be a less than compared to my y after I've divided by negative 1. And so I will be shading underneath of this line once I get it plotted. So first thing you should do is minus x from both sides. That's going to leave you negative y greater than or equal to, since I minused x, it's going to say negative x, positive 3 is plus 3, but I have to divide by negative 1 to clear out this negative. So now it says y, but this now, because this was a negative I divided by, has to flip, less than or equal to. Two negatives make a positive. It's a 1 divided by a 1. So this is just x, positive 1 slope. And 3 divided by negative 1 is negative 3. And so it's going to say x minus 3. So my intercept is negative 3. And I'm just going up 1 over 1. That's my slope. Up 1 over 1 all the way across. Now I do have an equal sign, so I can draw a solid line through these points. And like we discussed, it said greater than to start with, but it did flip when we divided by a negative. And so my shaded region must be underneath this line. Let's say for a second you did your intercept method. You plug in 0. Okay, you plug in 0 for y. It goes away. You just have x. So x is 3. Boom, here's your x-intercept. But what if you plugged in 0 for x? I'm left with negative y. For your intercepts, you would just say equals 3. You have to divide by negative 1, and so that gets you your y equals negative 3 when you divide by negative 1. And so there's my intercept of negative 3. Gives you those two right there. 17. All right, I'm going to go ahead and switch to my method of solving for y. I'm going to minus 3x on both sides here. When that eliminates, I'm still going to have a negative 4y. I have negative 3x minus 4. I'm going to divide by negative 4. Now I divided by a negative. This does need to flip this direction. Two negatives make a positive 3/4 x. Two negatives make a positive 1. I almost said 4. 4 divided by 4 is 1. So I'm going to hit at 1, and my slope is up 3 over 4. So down 3 over 4. It's a dotted line. And after the flip, it says greater than, so my shaded region is up here. Now, real quick, what if you decided you wanted to do your intercept method? So let's say you plugged in 0 for x. You're left with negative 4y equals negative 4. You divide by negative 4, and y equals 1. So there's my y-intercept of 1. Now, what if I plugged in 0 for y? That eliminates all of this. So I'm left with 3x equals negative 4. And when I divide by 3, I get this goofy intercept of negative 4/3. And so that's going to be a little bit past 1, which is where this is. Okay, but it doesn't give you a perfect number to put your intercept on. And so because of that, the intercept method is not the best method here. You're better off over here. All right, let's look at this one. Think of this when you go to draw the line as x equals 1. We've talked about these lines that are in this form. This is either horizontal or vertical when it's x equals or y equals. I always just think about it's going to hit the x-axis. It's going to hit whatever it says. And so x equals 1 is right here. It's not going to be a horizontal line. This is going to be a vertical line through that point. Now there's no equal sign, so this is going to have to be a dotted line straight down. It says less than. Now if this is a perfectly vertical line, less is going to be your left and right. Now we're talking about x, so I think it kind of makes sense. Here's your x value of 1. Everything less than 1 is over here. Okay, on number 19, I notice I have a negative in front of my y or a minus, so this will end up flipping. Don't forget to flip. It's going to say greater than. So first thing I'm going to do is minus 2x on both sides. Leaves me negative y less than or equal to negative 2x plus 4 because of the positive 4. Now divide by negative 1. When you divide by the negative, you're going to have to flip. So y is greater than or equal to 2 negatives make a positive 2x. Positive and negative make a negative 4. Okay, so my intercept is negative 4. And my slope is 2 over 1. So up 2 over 1. And because there's the equal sign, this is a solid line. It does flip and say greater than, and so greater than is going to be all of this. If you would use your intercept method, you would have got negative 4 for the y, and you would have got positive 2 for your x. Okay, over here, all I got to do is minus x, and I'm in good form, so this will not flip. The y is positive with its coefficient, so this will not flip. It is less than. Negative x plus 4 means I'm starting at 4. A negative 1 slope is down 1 over 1. Negative 1 over 1, down 1 over 1, all the way across. I do have an equal sign. So when I draw this line, it is solid. And it says less than, so my shaded region is down here. Okay, one thing you want to always notice if you're thinking about using your intercept method, if I clear this out, I'm going to have to divide 8 by 3. Not going to give me a perfect number, so not going to give me a perfect intercept. So I'm going to abandon that method right off the bat, and I'm going to go ahead and put this in y equals mx plus b form. So minus 3x to get rid of it. Keep the negative 4y. When you see that negative, you know that this is going to flip. This will be a greater than in the end. So I haven't flipped it yet because I haven't divided by a negative. Negative 3x plus 8. So I'm going to divide by negative 4 across the board. When I do divide by a negative, I have to flip this. Now it says greater. 2 negatives do make a positive 3/4. 8 divided by negative 4 is negative 2. So I'm hitting at negative 2, and I'm going up 3, and I'm going over 4. So down 3, over 4. I do not have an equal sign underneath my greater than, so this is a dotted line, and greater than is all of this. Okay, 22. Think of this like y equals 4. Hits the y-axis at 4. It's going across. It does have the equal sign, so this is a solid line. It does say less than. Think of all the y values that are less. That's everything down here. Okay, 23. If I put 0 in for y, I'd have to divide by 2. I don't get a perfect intercept, 3 divided by 2. Now that's not that difficult of a number because it comes out to 1.5. But all we have to do is move that 2x, and we're in perfect form. We will not have to flip anything. We have a positive coefficient, so it's negative 2x plus 3. I'm starting up at 3, going down 2 over 1. Okay, I do not have an equal sign, so this will be dotted. And it says greater than. Everything above in terms of y is over here. This one will be a good one for your intercepts. If you plugged in 0 for x, you have 2y equals 4. You would divide by 2, so y equals 2. That's a 0, 2 point. And if you were solving for x, you'd plug in 0 here, which would just leave you x and 4. So x is 4. So it's 4, 0. So 0, 2, 4, 0. Those would be your 2 points. If you did do it the other way, minus x. So 2y is less than negative x plus 4. You would divide by 2 across the board. So y is less than, this is negative 1/2 x. This is positive 2. I didn't divide by a negative. Okay, so I'm not going to flip this. It still says less than. This is a dotted line. If I had gone to this method, I would have started at 2 and gone down 1 over 2, down 1 over 2. You can see it would hit this x-intercept, and it says less than, and so my shaded region is down here.